So in this video, we're going to be looking at how we can find the number of real roots of a quadratic function. So the first thing that you need to be aware of is something known as a discriminant. So your discriminant can be described with the formula of d is equal to b squared minus 4ac. And you've probably seen this in the quadratic formula. That's one part of it, right? So we're going to be working with like one problem first, and we're going to go problem by problem to look at 3 different cases. So the first case we're going to be looking at is when our discriminant is greater than 0, right? And in that case, a quadratic has 2 distinct roots. All right, so let's look at an example here, right? Let's look at an example for my case. So let's say I had something like this. Let's say I had x squared plus 5x plus 2 is equal to 0. Okay, so I would firstly want to figure out what my a, b, and c values are. So by now I should be able to identify them. So I would have my a should be here, my b would be here, and my c would be here. Okay, so perfect. Now found our a, b, and c values. So now let's plug it into our discriminant. So remember our discriminant formulas, you may say. Remember your discriminant is equal to b squared minus 4ac. So what's my b? 5 squared minus 4 times 1 times 2. This is just 25 minus 4 times 1 times 2, which is minus 8. In this case, it's 17. So now we found our discriminant value. And since it's greater than 0, since my d value is greater than 0, my quadratic is going to have 2 distinct roots. And that's going to be our first case. All right, for case 2, when your discriminant of b squared minus 4ac is equal to 0, this means this. It means that your function, right, or your quadratic, I think quadratic is a better way to term it. So your quadratic is going to have one real repeated root. So basically occurs twice, but it's only one real root. It's a little confusing, but it basically just means that there's only one root, or one. I mean, in other words, I can just say one solution, right? It touches the graph once, or I meant to say it touches the x-axis once. Okay. So let's look at an example. Let's look at an example of this. Let's say we have something like this. Let's say I have x squared plus example. Let's say I had x squared plus 2x plus 1, right? And this is equal to 0. Now, remember your a, b, and c. Label that a, b, c, right? Let's plug into our formula here. So your discriminant is equal to b squared minus 4ac. So it's equal to b squared. So 2 squared minus 4 times 1 times 1. So it's just 4 minus 4 is equal to 0. So therefore, your quadratic function is going to have one real repeated root. And that's it. Now in our third case, we're going to be looking at when our discriminant of b squared minus 4ac is less than 0. So in this case, there are going to be, I'm going to repeat this, no real roots. Okay? So when your discriminant is less than 0, there are no real roots. Okay, so let's look at an example here. Let's say we had something like this. Let's say 3x squared plus 2x plus 1 is equal to 0, right? And in this case, let's list out our ABC values as normal. A, B, C, okay? Plug it in. Your discriminant is equal to b squared minus 4ac. b squared, 2 squared, minus 4 times 3 times 1. So it becomes 4 minus 12, and this is equal to minus 8, or negative 8. My bad. Negative 8 is a better answer for that. Negative 8. So in this case, our discriminant is less than 0, so therefore our quadratic function over here, right, of 3x squared plus 2x plus 1, or you can just say your quadratic, will have no roots. And that's it. That's all. These are basically 3 cases, and from these 3 cases, you can basically figure out how many real roots a quadratic has.